On this question, we want to find the domain of the function g of x equals 9x over x squared minus 4. And as we look at this function, we're trying to find the domain. We're looking for possible restrictions on the variable x. Now, one that stands out pretty quickly to me is that I see a variable in the denominator. And when you have a variable in the denominator, you have to consider division by 0 being undefined. And so you want to look for when that denominator is equal to 0. Now, before we do that, I just wanted to categorize this function as a rational function. A rational function is of the form f of x equals p of x over q of x. So we've got a fraction form when we have rational functions, and then specifically your numerator p of x and your denominator q of x need to be polynomial functions. And those polynomial functions are nice functions where the power on the variable is a whole number. So also right here it mentions that q of x is not equal to 0, and the reason for that is what we discussed just a moment ago, that division by 0 is undefined. So we can't allow that denominator to equal 0. Now over here, this is a discussion of how we're going to find the domain. Since rational functions are in the form of a fraction, we have a restriction that the denominator cannot be 0. You can find the restricted values by creating an equation. The equation is the denominator equal to 0. So that's going to be that q of x, whatever's in the denominator, equal to 0. Remember, division by 0 is undefined. The denominator equal to 0 will give us those restricted values. Once we solve this equation, the solutions to this equation are those restricted values, and they must be excluded from the domain. So let's create that equation for this example. Our denominator, q of x, would be x squared minus 4. We're going to set that equal to 0 so that we can find those restricted values. Now to solve this equation, this is a quadratic equation. There are many approaches you could take. We'll take the approach of isolating the square. So we're going to add 4 to both sides. X squared equals 4. Once we isolate the square, we'll square root both sides to get rid of that square. Square root and square are opposite operations. They cancel each other out, leaving us with x on the left. And then on the right, we're going to gain a plus or minus symbol. Every time you square root a square, you gain that plus or minus symbol. And square root of 4 is 2. So we came up with two solutions to this equation, plus and minus 2. That means we have two restricted values, positive and negative 2. And there are a couple different ways that we can write the domain once we know the restricted values. We can write the domain in set builder notation. In set builder notation, we use curly braces to indicate we're dealing with a set. We're going to use the variable x because we're dealing with the domain. We draw this vertical bar, that means such that. And then we're going to put the conditions on the set. So x is a real number, and x is not equal to plus and minus 2. So any real number not equal to positive and negative 2. And that's because positive and negative 2 make the denominator 0, which makes the whole function undefined. Another way we could write the domain would be in interval notation. So in interval notation, I like to draw a number line. and you're going to mark on that number line the restricted values of -2 and 2. We'll mark those restricted values with an open circle to indicate that those values are not in the set, and we can shade all of the other values. So this is a representation of all real numbers except for -2 and +2. And in interval notation, we want to represent each of these intervals. And remember that -2 and +2 are not included in the set, so we have to break at those values. We have to break up the interval at those values. So to represent this first one, we need to write the lower bound of -infinity and the upper bound of -2, and we're going to use parentheses on both of those. So that's indicating all the numbers from -infinity to 2. The next interval has a lower bound of -2 and an upper bound of 2. Once again using parentheses, so the parentheses indicate that the number is not included in the set. Just like open circle indicates that the number is not included, parentheses indicate that the number is not included. So this interval is including all the numbers between -2 and 2, but not the endpoints of -2 and 2. And then our final interval would start with a lower bound of 2 and continue on to infinity. We would put union symbols between these intervals, and this gives me the domain in interval notation. The domain of g of x equals 9x over x squared minus 4. Thank you for checking out my videos. Have a great day.